Today's lesson is sums of arithmetic and geometric series. So my learning objective for today is I can determine the sum of an arithmetic or geometric series. Sequence is a ordered list of numbers called terms, and a series is the sum of a sequence. Okay, the formula for the sum of an arithmetic series, S sub n. This is the sum of all the terms. Okay. N is the number of terms. A sub n is the first term. And A sub n is the last term. Okay, so I need to know, I need to know the number of terms, the first term, and the last term to be able to find the sum of the series. Okay, find the sum of the arithmetic series. So I'm going to start out with, my terms, this is my first term, my second term, my third term, my fourth term, and I don't know what my nth term is, but I do know I have 90 terms. So the previous lesson, we learned how to find an nth term. So I am looking at, I am going from 1 to 3, so I know my common difference is, I'm adding 2, right? Doesn't matter which 2 I'm using. When I take one term and subtract the previous term, I get 2. So the first thing I'm going to do is figure out my 90th term. So that is going to be my first term plus my common difference times the quantity n minus 1. So my first term is 1. My common difference we figured out is 2. And 90 minus 1 is 89. So 89 times 2 plus 1, I get my 90th term is 179. Okay, so now I'm going to substitute into my new formula. So my sum of my 90 terms is going to be n divided by 2. So 90 divided by 2 times the first term, which is 1, plus the last term, which is 179. So 180 times 90 divided by 2. So the sum of my 90 terms is 8,100. Okay. I can also see my terms in a different format where I have a summation symbol. So I'm starting here at n equals 1. This is my formula. So I'm starting here. So n, I'm starting with 1, and I'm ending where n is 60. So I can figure out my first term. So I would substitute n equals 1 for the variable. So this is going to be 4 times 1 plus 1. So 4 plus 1 is 5. So this is my first term. And then my 60th term is going to be 4 times 60. Oops. 4 times 60 plus 1, which is 241. So this is my 60th term. So now I know the number of terms, my first and my last term, so I can calculate the sum of all 60 terms. So I have 60 terms, so I'm going from 1 to 60, so 60 divided by 2, plus my first term, plus my last term. So the sum of all 60 terms is 7,380. Okay, let's try a real world. Stacking objects. Anytime we're trying to stack something, we usually want to know how many we can fit in the stack. Here we're talking about some logs. We're stacking them in a pile like this. How many logs are in the stack if the bottom row has 51 logs? Okay, so I'm starting at, this is my first row. So here's row 1, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 logs. So this is my first term. So row number 2, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Is 16 logs. So to go from 15 to 16, I know my common difference is 1. So I don't know how many rows I have. All I know is at the bottom, this row down here has 51 logs. Now, I could figure it out by counting and doing a difference here, but the point of this is to use the math and the formulas. Because in the real world, I don't necessarily have simple numbers that are close that I could just figure them out. So I'm going to use my formula to find my nth term. So I know I don't know how many rows I have, so I don't know what term it's called. But I do know if I add the first term plus the common difference of n minus 1, I do know that I have 51 in there. So I know my first term is 15. I know the common difference is 1. So n minus 1 equals 51. So now I have an equation with one variable, so I can solve for n. So the first thing I'm really doing is distributing 1 across the terms. So this is still 15 equals n. 15 plus n minus 1 equals 51. So I'm going to combine like terms. So 15 minus 1, so 14 plus n equals 51. And I'm going to subtract 14 from both sides. So I get n is 37. Okay, so I know I have 37 rows. Okay, so now I can find, since I know how many rows I have and I know my first and last row, I can find the sum. So the sum of my 37 rows of logs is going to be 37 divided by 2. My first row is 15 and my last row is 51. So I have a total of 1,221 logs. Here we go. Okay, so those are arithmetic sums. So let's do the same kind of examples, but this time with geometric series. So the formula for geometric series, the sum S sub n, a sub 1 is the first term, n is my number of terms, and r is my common ratio. Okay, so let's find the sum of the finite geometric series. So again, I'm going to start out with, I know this is my first term, my second term, my third term, and I have 9 terms. Okay, so to find my common ratio, I'm going to take any term and divide by the previous term. So I'm going to take negative 18 and divide it by negative 12, the previous term. So this is going to be 3/2 simplified, or 1.5 is my common ratio. So now I can substitute into my formula. Nope, I got to find my 9th term first. Nope, I only need the first term. I don't need the last term. So I can substitute in. So the sum of my 9 terms is my first term, which is negative 12. And this is going to be 1 minus my ratio. It's probably going to be easier to put this in as a decimal. 1.5 raised to the 9th power over 1 minus 1.5. So I get the sum of my 9 terms, and we want to show this as a fraction, is negative 57,513 divided by 64. I don't want a decimal because that would be rounding. I'm interested in an exact answer. All right, let's try an example with a sigma. So my starting value is at n equals 1. I don't have to start at 1, but this example is. So I'm starting at n equals 1, and I'm ending at n equals 8. So I know I have 8 terms. From 1 to 8, that's 8 terms. So I know n equals 8. To find my first term, because I just need to know my first term, I need to know 2 terms to find the common ratio if I don't understand what the common ratio is looking at the problem. So my first term, if I substitute n as 1, so this is going to be 0.3 raised to the first power. So that is just 0.3. So let's calculate the next term just so I can see what the ratio is. So this would be 0.3 squared, which is 0.9. I'm sorry. It's going to be, I'm just going to call it 0.3 squared. I'm going to do it that way because it's easier going to show it as the ratio. So my common ratio, I'm going to take my second term and divide it by my first term. So that is going to be 0.3 squared divided by 0.3 to the first power. So I am going to subtract, so I really get 0.3. So my common ratio is 0.3. Now going back and looking at my equation, I really see that That's the base here of this equation. So if I recognize it just looking at it, I don't have to find the next term and then do the division. Okay, so let's find the sum of our 8 terms. So I'm using my first term, which is 0.3, and 1 minus 0.3 raised to the nth power, which is 8, divided by 1 minus 0.3. Okay, so I get sum to the 8th, and we are going to round this one. This is 0.428. It turns out to be an irrational number, so I'm going to round. I don't have an exact number. Let's do another real world example. This one's a renting example. This is why everybody wants to buy a house, because rent, we just pay and don't get back. All right, so this is a cumulative rent. The Kemps have been renting a house for the past 6 years. In the first year of renting, they paid $600 per month. If their rent was increased by 5% for each year after that, what is the total amount of money they paid in rent over the past 6 years? Okay, so I'm going to start out with the rent. They're paying $600 per month. So I want to know how much they're paying for a year. So there are 12 months in a year. Oops. 12 months in a year. So 600 times 12 is 7,200. So we're paying 7,200 per year. Okay, so my ratio, it says there's a 5% increase per year. So my ratio is 100% plus 5%. So as a decimal, that is 1.05. So we talk in percents, but we work as decimals in the equations. So substituting in the sum of my 6 years is going to be the first year, which is 7,200 times 1 minus 1.05 raised to the 6th divided by 1 minus 1.05. So the sum for the rent that I paid for the 6 years is going to be $48,973.77. It's a lot of money. Okay, that's it for today.